A Neanderthal may have invented a tool that your species quietly kept. Around 50,000 years ago, in what is now southwestern France, someone took a rib from a large animal, shaped it carefully, ground the surface smooth, and created a tool for working hides. It was not a random bone used once and discarded. It had a standardized form, a curved tip, a polished working edge, a design still recognizable in leatherworking tools today. The strange part is who made it. The layer belonged to Neanderthals. Similar bone tools later became common among Homo sapiens in Europe. That leaves an uncomfortable possibility. The newcomers remembered as the technological geniuses may have arrived, looked at what the locals were doing and thought, we should absolutely pretend we invented that. But archaeology does not preserve patent records. A tool can reveal how it was made, what it touched, and sometimes which human population occupied the site. It cannot tell us whether the idea was taught during a peaceful meeting, copied from an abandoned camp, carried through intermarriage, independently reinvented, or acquired after somebody watched from behind a rock with professional interest. So did humans steal technology from Neanderthals? The honest answer is that they almost certainly exchanged knowledge, because the two populations met, lived near one another, and had children together. But proving that one specific invention crossed in one specific direction is much harder. The evidence does not show clever humans arriving among mindless Neanderthals. It shows two kinds of human entering the same landscape with different traditions, similar problems, and enough contact for biology itself to cross the boundary. Tools probably crossed too. Let's go through it properly. First, we need to remove the word technology from the modern office where it has been trapped. Technology is not only electronics, engines, or something requiring a password reset. A prepared stone core is technology. Cordage is technology. Glue is technology. A wooden spear balanced correctly for thrusting or throwing is technology. So is the sequence that turns an animal hide from stiff, decaying skin into flexible clothing capable of keeping a child alive through winter. The object is only the visible end. Behind it sits knowledge. Which stone fractures predictably? How dry should the wood be? Which part of a bone bends without snapping? How do you heat bark into adhesive without burning away the useful material? How do you bind a point to a shaft so that it survives impact? A child cannot discover all of that before breakfast. Complex technology accumulates because people learn from other people. Neanderthals had been doing this across Europe and Western Asia for hundreds of thousands of years before the last major expansion of Homo sapiens into Europe. They made sophisticated stone industries, controlled fire, hunted large animals, hafted stone points onto handles, used pigments, worked wood, and adapted to environments ranging from Mediterranean woodland to cold steppe. They were not waiting inside caves for modern humans to deliver the concept of competence. One of the clearest examples is adhesive. At sites associated with Neanderthals, archaeologists have found birch bark tar used to attach stone tools to handles. The oldest known examples reach back roughly 190,000 years in Europe. Birch bark does not naturally offer a convenient lump of finished black glue. It must be heated and transformed. Experiments show that several Stone Age methods can produce usable tar, ranging from relatively simple open-air collection to more controlled structures. We still do not know which exact method produced every ancient sample, but the substance itself records intentional material transformation. Neanderthals were not merely selecting a sticky thing. They were manufacturing one. They also made cord. At Abri du Maras in France, researchers identified a tiny fragment of 3-ply cord attached to a stone flake from a Neanderthal context dated to between roughly 41 and 52,000 years ago. Inner bark fibers had been separated, twisted into strands, then twisted together in the opposite direction to form stronger cordage. The surviving fragment is only a few millimeters long. The missing technology is enormous. Once a population knows how to make cord, it can bind tools, create nets, fasten clothing, carry loads, build traps, join shelter frames, suspend objects, and eventually produce things archaeology almost never preserves. A cord fragment is not one invention. It is evidence of an entire category of vanished objects. Then there were the lissoirs. These were specialized bone tools, usually made from ribs, shaped and polished into smooth, curved ends. Their likely purpose was working hides by applying pressure without cutting the surface. The action could soften leather, close pores, and create a more water-resistant finish. Researchers found 4 examples in Neanderthal layers at Pech de Laze 1 and Abri-Peyroni in France. They dated to before the period when comparable standardized bone tools became widespread among incoming modern humans in Western Europe. The authors raised the possibility that Neanderthals invented the form and that Homo sapiens later acquired it. This is one of the strongest candidates for technology moving from Neanderthals to us. It is still not a signed confession. Perhaps early Homo sapiens elsewhere already made similar tools from materials that did not survive. Perhaps both populations recognized independently that a rib has the ideal shape for rubbing hide. Ribs are curved. Hide is difficult. Evolution did not need to arrange a conference. But sequence matters. When a distinct tool appears earlier in one population's secure context and later becomes common in another population occupying the same region, transmission becomes a reasonable possibility. Not proof, possibility. That distinction will follow us through the entire story. For a long time, the traditional narrative moved in the opposite direction. Neanderthals were portrayed as technologically conservative. Homo sapiens arrived with blades, bone tools, ornaments, symbols, larger social networks, and the archaeological equivalent of a product launch. Neanderthals then either copied the newcomers briefly or disappeared before understanding the update. This story centered on a tool tradition called the Châtel-Perronian. Around the final millennia of Neanderthal life in Western Europe, archaeological layers in France and northern Spain began containing a distinctive combination: backed stone knives and blades, bone tools, pigments, and personal ornaments made from teeth, bone, ivory, and shell. Some of those objects looked more like the material culture associated with Upper Paleolithic Homo sapiens than the older Neanderthal Mousterian industries beneath them. Then, Neanderthal remains appeared in Châtel-Perronian contexts. At Grotte du Rhin in France, layers containing ornaments and worked bone also contained Neanderthal teeth and bone fragments. Critics argued that the cave layers had become mixed, allowing later objects made by Homo sapiens to move downward beside older Neanderthal remains. In 2016, researchers used ancient proteins, mitochondrial DNA, and dating to identify additional Neanderthal remains securely associated with the Châtel-Perronian levels. The association became harder to dismiss. Neanderthals had used at least some of this apparently modern toolkit. But where did the ideas come from? One model is acculturation. Incoming Homo sapiens entered nearby regions carrying new blade technologies, ornaments, and bone-working traditions. Neanderthals saw those objects through contact or exchange and adopted selected elements while maintaining much of their own stoneworking system. Under this model, the Châtel-Perronian is not evidence that Neanderthals lacked intelligence. Copying a foreign technology, fitting it into an existing tradition, teaching it, and preserving it across generations are advanced cultural abilities. Anyone who has watched a relative fail to connect a printer should approach prehistoric learning with humility. The alternative model is independent Neanderthal innovation. The Châtel-Perronian may have grown from local Mousterian technology before meaningful contact with modern humans in the relevant region. Its blade production shows connections to earlier Neanderthal methods, suggesting local development rather than simple imitation. Personal ornaments and specialized bone tools could have emerged from Neanderthal social change, population pressure, or communication needs of their own. This view asks a fair question. Whenever Homo sapiens makes a new object, archaeologists call it innovation. Whenever Neanderthals make one, why must a sapiens be hiding nearby with instructions? Chronology should settle the argument. Unfortunately, chronology entered the cave and immediately became complicated. The arrival of Homo sapiens in Europe was not one clean wave moving west on a visible line. Recent discoveries show early groups in different regions by around 45,000 years ago or earlier, sometimes associated with industries once difficult to assign to a species. At Ranis in Germany, human proteins and DNA connected Homo sapiens with the Lincolnbian Renisian Gersmanophysian industry around 45,000 years ago. At Bacho, Cairo in Bulgaria, early Homo sapiens were associated with initial Upper Paleolithic artifacts, and several had Neanderthal ancestors only a few generations back. The two populations overlapped in Europe for thousands of years. Not everywhere, not continuously, but enough. This makes influence possible without making it visible. A Neanderthal group in France did not need a modern human family living in the next cave. Objects, people, and ideas can move through chains. One group meets another. A marriage partner changes communities. A tool is traded. A visitor demonstrates a technique. A style passes from camp to camp until its origin becomes irrelevant to everyone except archaeologists 40,000 years later. The genetic evidence proves intimate contact. Some of the earliest Homo sapiens found in Europe had recent Neanderthal ancestors. The Bacho-Quiro individuals carried long stretches of Neanderthal DNA, showing that interbreeding had occurred only several generations earlier. Modern human populations outside Africa still carry Neanderthal ancestry from earlier mixture in Eurasia. People who shared children could have shared glue. That does not mean every encounter was peaceful or equal. Interbreeding can occur through alliance, adoption, migration, coercion, conflict, or relationships we cannot reconstruct. Genes crossing a boundary prove contact, not friendship. Still, the image of two species existing as isolated teams with separate toolboxes becomes difficult to maintain. They met. They recognized one another as socially possible partners at least sometimes. They watched each other do things. That is more than enough for cultural transmission to begin. A new discovery from Saint-Césaire has made the Châtel-Perronian debate even more interesting. Researchers reported shell beads and pigments directly associated with Châtel-Perronian artifacts in carefully analyzed deposits. The find expands evidence that these communities used personal ornaments beyond the famous Grotte du Rhin collection. A bead is technologically simple compared with birch tar. Socially, it may be more complicated. To make a personal ornament, someone chooses a material, modifies it, it, suspends or attaches it, and displays it where other people can interpret it. The object may signal identity, status, group membership, age, personal history, or simply the ancient discovery that shells look excellent when worn near the face. If Neanderthals adopted beads after seeing Homo sapiens use them, the transfer was not only technical. It involved understanding that an object could communicate. If they developed the tradition independently, then symbolic display was not a sapiens monopoly. Either answer damages the old caricature, but we should also resist the reverse caricature, the idea that every technology belonged to Neanderthals first and Homo sapiens succeeded by stealing the useful parts. Our species arrived from Africa and Western Asia carrying extremely deep traditions of its own. By the way, if you want to go even deeper into the secret lives of ancient humans, I just launched a full course called The Secret Lives of Ancient Humans. 10 modules, 3+ hours of content covering everything we never talk about on YouTube. What they feared, how they communicated, what hunted them, and much more. Plus an exclusive PDF guide included. Link in the description. See you inside. Homo sapiens populations had developed adhesive technologies, bone tools, engraved objects, shell ornaments, pigments, heat-treated stone, and long-distance material networks long before entering the final Neanderthal territories of Europe. Modern humans did not arrive empty-handed. They brought toolkits shaped by many environments and many populations. The encounter was not between inventor and thief. It was between two technological lineages. This matters because similar tools do not always require copying. Stone fractures according to physics regardless of who strikes it. Animal ribs offer similar shapes. Hides demand similar treatment. A sharp point works better when fixed to a handle. String becomes stronger when fibers are twisted. Human hands. Confronting the same materials may converge on similar answers. Archaeologists call this equifinality. Different behaviors or pathways can produce similar results. A backed blade might spread through teaching. It might also emerge independently because blunting one edge allows a sharp stone insert to be held or mounted safely. A shell may become a bead through imitation. It may also have a natural hole that makes the idea almost offensively available. This is why technology transfer requires more than resemblance. Researchers look for detailed manufacturing sequences. Where was the striking platform prepared? How was the core maintained? Which mistakes appear? What raw materials were selected? Does the entire chain of actions match or only the final shape? A copy tradition often preserves small choices that are not mechanically necessary. Two knives can look alike while being made through different mental templates. Conversely, tools that look different may come from related production knowledge adapted to different stone. The invisible process matters more than the silhouette. This is one reason the Châtel Perronian is so heavily debated. Its stone technology contains local Mousterian roots even while parts of the broader assemblage resemble incoming Upper Paleolithic behavior. That mixture could represent Neanderthals selectively borrowing ideas. It could represent independent change happening during a period of contact. It could represent communities whose identities were already more mixed than the labels imply. The labels themselves can mislead us. Neanderthal technology sounds like every Neanderthal across Europe followed one manual. They did not. Their stone traditions varied across regions and time. Materials, prey, mobility, climate, group size, and cultural history all changed the toolkit. Homo sapiens technology is even broader. African and Eurasian sapiens populations developed different industries. The first modern humans reaching Europe did not all carry one standardized cultural package. Some early industries are now being linked to sapiens only because proteins and DNA have finally identified the people behind the stone. Species are biological categories. Technologies belong to communities. A person can change communities. A child can have ancestors from both populations. At that point, asking whether humans stole from Neanderthals begins to resemble asking which side of a family invented the recipe after everyone has been eating together for 3 generations. There is also the problem of preservation. Stone survives beautifully because stone has very little else planned. Wood, fiber, hide, bark containers, nets, straps, woven mats, plant medicines, and most adhesives disappear. The archaeological record therefore exaggerates the importance of stone and undercounts technologies in which Neanderthals may have been highly skilled. The cord fragment from Abri du Maras survived by extraordinary luck. Without it, we might still argue that Neanderthals probably made string but lacked direct proof. How many other technologies disappeared completely? A net can transform hunting. A basket transforms gathering. A sling transforms distance. A tailored hide transforms winter. None needs to leave more than a faint trace. When Homo sapiens later produced similar perishable technology, we cannot compare it with Neanderthal examples that no longer exist. Absence becomes silence, and silence is easily mistaken for inferiority. Demography may have mattered more than intelligence. Neanderthal populations were generally small and often isolated. Small groups can invent impressive things, but innovations are easier to lose when only a few people know them. A skilled maker dies. A winter kills one family. Two groups stop meeting. The technique disappears and must be reinvented. Larger, more connected populations preserve knowledge more reliably. They expose individuals to more teachers, more materials, more variation, and more opportunities for an idea to spread before local disaster erases it. Homo sapiens may have possessed broader social networks in some regions, giving their technologies greater cumulative stability. This does not require a superior individual brain. It requires more brains remaining connected. The difference between a brilliant isolated inventor and a civilization is often storage. Culture stores information in people. Networks provide backups. Contact with Neanderthals could therefore have benefited Homo sapiens even if sapiens populations eventually replaced or absorbed them. Local Neanderthal groups knew European landscapes intimately. They understood raw material sources, animal movements, seasonal dangers, and technologies refined under regional conditions. An arriving group does not need to copy an entire culture. It only needs to learn one useful thing: which stone source lies beyond the ridge, how to process a hide for colder conditions, which adhesive works with local birch, where reindeer cross, how to shape a bone tool that modern leatherworkers still recognize. This knowledge may have moved through individuals whose ancestry was mixed. A child raised in one community could carry techniques learned from a parent or grandparent born in another. The artifact would later be classified under whichever archaeological culture surrounded the child's adult life. The technology would cross species without crossing a battlefield. Stealing is therefore the wrong word. There were no intellectual property laws. Knowledge in small oral societies spreads through watching, participation, correction, exchange, and memory. Copying is not cheating. It is one of the central human survival skills. Neanderthals copied one another. Homo sapiens copied one another. Both probably copied useful behaviors from the other when contact allowed it. The more interesting question is why scholars once resisted that possibility. Partly because Neanderthals were discovered inside a 19th century hierarchy obsessed with progress. Their heavy brows and robust skeletons were turned into personality traits. They became primitive, slow, violent, and doomed. The biological rough draft that our species improved. Every sophisticated Neanderthal object then became a problem. Perhaps the layer was mixed. Perhaps the object was accidental. Perhaps modern humans made it. Perhaps Neanderthals copied it without understanding. Skepticism is necessary in archaeology. Layers really do mix. Dates really do fail. Simple processes can create objects that look complex, but skepticism applied only in one direction becomes a story protecting itself. The current evidence shows Neanderthals manufacturing adhesives long before the final contact period, producing cord, shaping specialized bone tools, maintaining regional stone traditions, using pigments, and creating or adopting ornaments. They were capable of innovation, social learning, and cultural change before their disappearance. Homo sapiens brought equally real innovations and probably stronger networks for accumulating them. When the populations met, the result was not a clean contest between intelligence levels. It was contact between cultures. Some ideas may have moved from sapiens to Neanderthals. The timing and appearance of Châtel-Perronian ornaments make that plausible. Some may have moved from Neanderthals to sapiens. Lissoires remain a serious candidate. Some technologies may have been invented independently. Some may have passed through mixed families so completely that assigning ownership is meaningless. And some evidence has vanished, leaving arguments built around 6 millimeters of cord and a few bones polished by hands that cannot answer questions. So did humans steal technology from Neanderthals? Probably not in the dramatic sense. There was no midnight raid on a Neanderthal workshop followed by sapiens fleeing with the secret blueprints for leather. But did Homo sapiens learn from Neanderthals? Almost certainly. It would be extraordinary if they did not. The groups overlapped. They interbred. They occupied neighboring landscapes. They made technologies that sometimes resemble one another, and at least one specialized bone tool appears earlier in Neanderthal contexts than in the widespread modern human record of Western Europe. The exact roots remain uncertain. That uncertainty is not failure. It is the correct shape of the evidence. Archaeology can show contact. It can show sequence. It can show similarity. It can sometimes identify the hands behind an industry. What it rarely preserves is the lesson. A Neanderthal presses a polished rib against hide. A sapiens visitor watches, or the scene happens in reverse. Someone asks to hold the tool. Someone demonstrates the movement. A child remembers. 40,000 years later, we find the object and argue over which species deserves the credit. The people involved may never have cared. Useful knowledge had moved. That was enough. We did not replace Neanderthals without taking anything from them. We carry pieces of their genome. We may carry pieces of their technology. And the deepest Neanderthal invention Homo sapiens preserved may not have been one tool at all. It was the habit both populations shared. Watch another human solve a problem. Then keep the solution.